jump over here, click on this, and open up the chat. All right. So, no real announcements. Let me give everybody a moment. I'll unmute everybody, or allow you to unmute yourselves for a moment. Did anyone want to ask any questions? So we're at the end of week 5. We're going to just keep moving forward with the schedule as listed in Blackboard. So we're going to keep going through section 1.4, a library of functions. Did anybody have any questions they wanted to ask before we get started?
No, sir, but I did want to inform you that now that my 14 free day trial on Pearson's up, until I can buy the code for it, I'm unable to access any work on Pearson.
So then what you'd have to do, you can go ahead and make another account with a different email. Like everything can stay the same, use a different email. Make another account and just keep working. I think what I can do...
You're kind of low again.
I was going to say just basically make another account and keep working. And then once you get full access, we can try to put all that back in one account or something like that.
Yes, sir.
Yeah, but the thing is, you want to just keep working. Don't sit idle because it's real easy. This stuff will pile up fast. I don't
yes, sir.
Yeah. Any other? Yep, no worries. Any other questions, comments, or concerns before we kind of keep it moving?
Yeah, I also had that same problem, but you said just change your email.
Make a new account with a different email. Keep working, and then once you get full access, just let me know, and we'll figure out how to get your stuff back on your main account.
Okay.
I have a concern too. My Zoom link, I tried to use the first one that you gave us on Blackboard, but then it just updated me with a new one. So yeah.
Yeah, it's fine because I intentionally I'm not using that link. I just making a new one every time for right now.
Okay.
Yep. Okay. And so as we make our way through the homework on Pearson, if anything is not clear, just again be sure to make use of the Ask My Instructor. So from here on out for the rest of the class, let me go ahead and do this. I'm going to be monitoring the chat, so you could actually watch the live stream on YouTube. We are streaming live on YouTube. I think I finally worked out my kinks, right? And I got it behaving the way that I wanted to behave. Let me do this because I know how that behaves. Let's go ahead and reload that. Give me a moment. Okay, but yeah, I think I worked out the kinks. So we are streaming live on YouTube, so we can pull a copy there. Right now I have it set that you should not be able to unmute yourself. Yeah, so yeah, I'm gonna monitor the chat, so you can actually use the live chat to kind of get my attention. So it's there. Okay, so I'm just gonna kind of keep the live chat. I'm gonna monitor that. So yeah, if you have a question or comment, just type it into the chat, and I'll be referencing that periodically. Otherwise, I'm going to kind of focus and try to finish. I just need a clock. Try to finish. I think there is a way to kind of activate the screensaver. How do I do that though? What if I go like this? That's not it. What if I do this? No, I was trying to turn it off. What did I used to press to get that to work? No. That's not what I really want to do. Sweet. Okay. Okay, yeah, that's exactly what I want. Only other thing that would make it better is a clock. Can I get a clock? No? Okay, that's okay. The whole point I was doing that, I did want a clock. There's no clock there either. Oh. Okay, anyway. So let me see. This we run from 2:25, I think, until 3:30, right? Let me see. Actually, I was just from the last meeting, couldn't get back in. No, I'm not going to penalize you. Once I take attendance, I'm not going to make a big deal, right? I'm really just using attendance just to check in, have an opportunity for us to check in. I don't make a big deal. I don't make a big deal from that point forward. Once you get attendance credit for the day, you're good for that day. The sessions are available, so you can always review them. If you get booted, hopefully you have one of your classmates contact and just reach out to us and say, hey, I'm trying to get back into class. Let me know and I'll unlock it. I know I'm going to lock it in a few minutes, so I should have a timer going off. I do intend to lock it in a few minutes just to kind of keep nonsense down. Okay. But yeah, I'm not going to penalize you. But we're still responsible for getting the material, the content. Okay. All right. So let's pick back up where we left off from. We left off. I'm gonna just kind of jump forward, try to get to where we left off. We left off about here, right? So the last thing that we were working on, we graphed a piecewise function. So that was Tuesday. So then today is the 17th, 225. We want to graph the greatest integer function. Okay. So this function did not display properly. Let me at least show the proper display. So let me kind of edit this. I'm gonna copy, paste. So essentially that did not display properly. And basically the greatest integer function, it looks like this. It's like a square bracket on either side, but then there's this extra bar like this. That's essentially the greatest integer function. All right. That's what it's supposed to look like, something like that, right? That symbol, it's all over the place. Let's I think the image might be a little bit better. Let's go like this. Let's copy. Okay. Oh, you're starting to do this thing. Oh, you suck. Come on. Don't do that. Damn it. That's so irritating. I don't even understand why I was doing that. Let me cut. I gotta try to get all the way back over here. Right here. I don't understand why I was doing that. Can I just, can I duplicate this? Copy. I don't know why it's doing that. Can I leave that there? Okay, let me try this. Okay. For some reason, it's kind of okay. I think I know why it's doing that, but I don't know how to fix it right now. But all of these symbols are supposed to look like the one on the upper right. So all of these are wrong. I guess another thing that I could do, I can at least blot them out. Blot it out. Blot this one out. And I can at least manually write it in. Okay, yeah, I think we got something functional. All right. Oh. Okay. So the greatest integer is going to be the integer less than or equal to whatever the number is, right? Let me see. So graph the greatest integer function. It says choose a closed interval between two consecutive integers. Say this. So if x is greater than or equal to 2 but less than 3, then the answer is going to be 2. If x is between 1 and 2, the greatest integer less than or equal to our x is going to be 1, right? So the values of the greatest integer are constant between each pair of consecutive integers and jump by 1 unit at each integer. So the graph is going to look something like this, right? Let's hit paste and let's blot that out. This guy. Right. So, undo. That's fine. So the greatest integer function looks like this, right? So say x were 2.7, right? Notice that 2.7 is between 2 and 3, so it collapses to 2, right? So as long as whenever our number is between two integers, we take the integer to the left. That's how the greatest integer function works. It's kind of like a floor function, okay? It says the following are some of the common functions of algebra along with their properties and should be included in a library of basic functions. So the first basic function that we have is called the constant function. It's y equals c. So y equals a number. It's just going to be a horizontal line through y equals that number, right? So notice, think about for a moment, what's the domain here? The domain. In a graphical sense, domain is the very left to the very right. How far left does the graph go? The far left is negative infinity. How far right does it go? It's infinity. How far down does this graph go? How far up does this graph go? So the very top to the very bottom is actually the same thing. It's neither going up nor is it going down. So whatever that c value is, it's just going to be just that c. And this is going to be constant over the entire domain, so it stays flat over the entire domain. And this function, I think is even. Let me think about it. It should be symmetric. Oh, there's no x, right? So this function is neither even nor odd. It should have y-axis symmetry though. Let's see what it says. It's an even function. Oh yeah. F of negative x, no x, right? So again, the domain here is all reals. The range is going to be just c. It's constant over the entire domain. Again, this function has y-axis symmetry, so it's even, right? If we did f of negative x, we still get back the original function. So that's the definition of a function being even. Even also means that it has y-axis symmetry. We can fold it on the y-axis and it'll match up. Okay. For a moment, I want you to think about what's the domain of this. How far left does this graph go? Right. So the domain being the very left to the very right is going to be negative infinity to infinity. The range being the very bottom to the very top. That's totally distracting. So I guess they're doing another Bill and Ted movie with like Keanu Reeves. And so it's like on my screen right now and it's totally distracting. No, yeah, that's fine. That's what I want. That'll be better. It's something that's not distracting. Okay. So the domain being the very left to the very right. And again, I am monitoring the chat, so if anything isn't clear, just type in the chat and I'll pause. But the domain should be all reals. The range should be all reals. This function is increasing over the entire domain. So as we trace it left to right, it's going up. So it's increasing over the entire domain. And this function is odd. So if we did f of negative x, we'll get back negative f of x, right? Negative of the original. So that means we have origin symmetry. So the domain and range are all reals. It's increasing over the entire domain, and this is an odd function, which means we have origin symmetry. Okay. So we've done the constant function, which is just a horizontal line. Ali, yeah, you can hear me. We've done the identity function, which is just basically y equals x. So next we have the squaring function, right? So what's the domain here? So squaring function is like y equals x squared. Think about what's the very left to the very right, right? And you can type your responses in the chat. Like, it's okay. Like you wanna try to get some feedback. It's okay to be wrong. Like we're here to get it wrong. We're just doing the best we can to try to like sort this out before a crucial moment like an exam or something like that. But the domain here, the very left to the very right, is going to be all reals. the range being the very bottom to the very top. Can someone in the chat tell me how far down does this graph go? What's the very bottom? What's this y value here? How far down does the graph go? So, let's see. I think that's available. Yeah, it should be. Okay, so the very bottom is 0, and we actually do include the 0 here. And what's the very top? How far up does the graph go? It goes all the way to positive infinity, right? So the range is going to go from 0 to infinity, and since we do actually reach 0 in this case, the 0 is going to get a square bracket. As we trace it left to right, is it increasing, decreasing, or constant initially? Like, what is it doing first? Is it going up, going down, or staying flat as we trace it left to right? So as we trace it left to right, initially it's decreasing, right? It's decreasing from the far left is negative infinity up to x value of 0. And then it's increasing from x value of 0 off to the far right? And this function is even. So even means if we did f of negative x, we get back the original, which means also that we have y-axis symmetry. Okay. So we see the domain. Notice the range, we did a square bracket, which means we include the 0. We said it's decreasing on the left half, and it's increasing on the right half, and it has y-axis symmetry, so it's an even function. Okay. Keeping it moving. What's the domain here? Very left to very right. I'll say the domain and range here are both all reals. As we trace this graph left to right, it is increasing the entire time. And it actually has origin symmetry. So this function is odd, which means if we did f of negative x, we're going to get negative f of x, negative of the original. Okay. That's called the cubing function, y equals x cubed. Absolute value. What's the domain? The very left or the very right? The far left, negative infinity to infinity. The range is 0 to infinity. 0 gets a square bracket. It's decreasing from negative infinity to 0. It's increasing from 0 to infinity. And the function is even. If we did f of negative x, we get back the original. So we're going to have y-axis symmetry. Hopefully some of this stuff is sinking in, okay, with these examples. Next, we have the square root function. The square root function is like the top half of a sideways parabola, right? So the domain here, the very left, the far left is here, and the far right goes off that way. So the domain here will be 0 to infinity, as well as the range is also 0 to infinity. The range being the very bottom, and how far up does it go? It goes up to infinity. As we trace it left to right, the function is increasing. It's going up and up and up and up. It's going to keep going up. So we say that this function is increasing over the entire domain of 0 to infinity. And there's no symmetry going on here. It's neither even nor odd. Okay. So cube root is a similar discussion. I'm just going to kind of leave that one. This is the reciprocal function. The reciprocal function, we have a horizontal asymptote in this case, which is going to be the x-axis. We also have a vertical asymptote, which is going to be the y-axis. So with the asymptotes, we get really, really close to those, but we don't cross them. Like in the long term, we're going to be close to these asymptotes, right? So the domain, the very left to the very right, is going to the far left, every x is accounted for. There's only one x value that's not accounted for here. The only x value that's not accounted for is x equals 0. There's an asymptote there, right? So the domain is going to be everything except 0. And I think the range is the same thing, everything except 0. Okay. As we trace this left to right, the function is going down, 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 down. And as we continue tracing left to right, it's going down, 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 right? So we say it's decreasing over the entire domain. Decreasing over the entire domain, which is basically everything except 0. And this function has origin symmetry. Okay. Okay, if we do f of negative x, we get negative of the original. So that means we have it's odd and we have origin symmetry. So greatest integer function. So again, that function looks like this. Okay. What's the domain? Is there any x that's not accounted for? All right. So no matter what x we choose, we can find the corresponding y. So the domain here, we would say, is all reals. Every x is accounted for. But can someone tell me the range? What are the y values here? Can anybody tell me the range here? What are our y values? Possible y values? Or at least give me just one possible y value for this. Anybody give me, okay, so 3 and negative 3, those are some y values. So we have 3 and negative 3, right? So, for instance, y equals 3 is here. Sorry, y equals 3 is here. Y equals negative 3. Y equals 2 is also a result. Y equals 1 is a result. Y equals 0 is a result. 1, 2, 3. What about 4? Is 4 possible? Is 4 possible with this step function? So 4 is possible. You know, we just can't draw the thing forever. So we have to be aware that we're continuing the pattern, right? Okay, 4 is possible. What kind of numbers did I just describe? If we're doing, for instance, 0, if we're doing like 0, 1, negative 1, 2, negative 2, 3, negative 3, 4, negative 4, 5, negative 5, 6, what kind of numbers are those? What set does that belong to? Begins with an I. So that's actually the set of integers, right? So the range for the step function is going to be the integer. We said that this is constant over the domain, but we would say that it's constant on the segments basically from like negative 1 to 0, 0 to 1. Like we write them out separately, I think. It's constant over those intervals. I think we have, if we rotate that, does it match up? No. I don't think there's any kind of symmetry here. I was trying to see if there's origin symmetry, but it doesn't look to be. So I'm going to say that it's neither even nor odd. Let's see how do we do. Okay, so every x is accounted for in the domain. The range is a set of integers. Okay. And we said that it's neither even nor is it odd. Let's see about increasing, decreasing, and constant. They didn't do it. Y'all suck. Let me copy. Can I just copy this? That'd be nice. Copy. Paste. That's fine. That's all I wanted. All right. Okay. So the average rate of change. Average rate of change of a function, right? So for our purposes, average rate of change is nothing but the slope between points, right? It's nothing but the slope between points. What's the time? Man, this class goes by so fast. I love this class so much. I blink my eye and it'd be over. I be like, oh, we got to try again next time. But we're actually almost done with this half of this lecture. It says the average rate of change of a function. So let a comma f of a and b comma f of b be points on the graph of a function. Then the average rate of change of f as x changes from a to b is going to be defined as this, as long as a is not equal to b, right? So basically, it's the slope between 2 points of a function. So y2 minus y1 over x2 minus x1. I wonder if I can make that my background. So it's doing these like screensavers. They have the Apple TV showing like screensavers. I'm kind of curious. Let me see. Just having a little bit of fun. Let's see if I can make that my background. It's too much more than I want to do for right now. I'll try that next time, maybe if I can see if I can get that to work. I'll try it next time. Okay, right. So average rate of change for our discussion is essentially just the slope. It's just the slope. Okay. So in this example, we're asked to find the average rate of change as x changes from 1 to 3. All right. So basically, find the slope. Right. So average rate of change here. So the average rate of change we said was f of b minus f of a. Sounds like somebody just left. Hopefully they got somebody's contact and they can get back in, but I'm not going to worry about it. F of b minus f of a over b minus a. Okay. We probably should have like written out our ordered pairs or whatever. But. So our b is 3, right? So if we plug in 3, that's a 9 times 3, that's a negative 27. 2 minus 27 is negative 25. So we get negative 25 minus, when x is 1, that's going to be negative 1, so it's going to be plus 1 over 3 minus 1. Negative 24, so that's going to be negative 24 over 2, which is negative 12. Nope, that's not it. There it is. Okay, I think we got the same thing as the text. Find the average rate of change of this as t changes, as t equals 5 to not 5. Find the average rate of change as t goes from 5 to anything other than 5. Oh, so you can do it like coming from the right and the left, right? So it's the limit as it gets closer and closer, so it's kind of like that. Okay, so like for instance, if we came from the right, say we did as t goes from 5 to 6, we can do 6, we can do 5.5, we can do 5.1, 5.05. I think I would use my calculator or a spreadsheet there. Average rate of change. Oh, okay. I see. So the second one we left is open, right? Okay, let's see if let's just do that really quickly. So they left the second one open. All right. So then here, we're gonna do f of b minus f of a over b minus a. So let's do, so the b is x. So we're gonna do f of x minus f of 5 over x minus 5. Let's just do this and see what happens. So this is, oh, and I guess there should be a t instead of an x. So that's going to be 2t squared minus 3. And then t of f of 5, 25 times 2 is 50, minus 3 is 47. Okay, let's keep going. What is that, negative 50? So we can factor out a 2. 2 times t squared minus 25 over t minus 5, right? Waiting room, he got booted. Okay. Not the meeting. So tell them it's unlocked to just, there it is. Admit. Okay. Let's see. So now at this point we have difference of squares, right? It's a special factoring, so this is going to become t minus 5 times t plus 5 over t minus 5. And then this cancels this. Two t plus 10. Let's see if we can put this into some context. Okay. What's the time? So then I think that what this is this creates a formula for us. So then it's like, okay, given, I don't know if it's supposed to be x or it's supposed to be t. I mean, for right now, we're not going to make a big deal about that. But so this will tell us like, basically it should tell us the slope for any x. Like for instance, if x were 6, then it should tell us the rate of change as x goes from 5 to 6. We can basically let x be whatever we want. I'm going to let that be. Okay. For function f, this is called the difference quotient, all right? Let me just try to keep this as simple as possible. So this kind of like, the difference quotient is a precursor to something that's in calculus. In calculus, we talk about derivatives, and derivatives is like the slope of a tangent line either at a point, well, yeah, derivative is at a point, right? But this is the precursor to that. Derivatives are actually really easy. I enjoy derivatives. Let me say that. I don't know if easy is the right phrase to use, but they're fun. Especially once you learn the shortcuts for derivatives, then you can look at a question and get it quick, right? But what we're doing is like a precursor to the longer version of find a derivative. And it just kind of primes us to be able to do this major thing. That's like most of calculus is differentiation. And we don't really do it this way in calculus. In calculus, we can look at it and we have shortcuts that go like bypass all the stuff we're doing here. But for our purposes, we're going to be using the difference quotient, and that's what this is. And so this comes out of like if you have a curve, and you have a point on the curve, and then you have a second point on the curve, and so suppose we consider the slope of the secant line between that first point and the second point, and as that second point gets closer to the first point, the slope of the secant line is going to be a better and better approximation to the slope of the tangent line. A tangent line is going to be a line that intersects a curve at one point in this fashion. A secant line is going to intersect a curve at more than one point, right? So what we're doing is, in calculus, what we would do, we would take the limit as this change gets smaller and smaller and smaller, basically as this change goes to 0, right? That's what we would look at in calculus. And again, it sounds like a mouthful. The backstory is a little bit involved, but once you get into like, you get past the backstory and you start actually doing some application, they're fun to me. They go really quick. There's the shortcuts are just like you look at it and you can write the answer down. But again, for our purposes, we're going to be working out the difference quotient. So hopefully I didn't like scare you guys away from calculus. But it's fun. I'm telling you, it's fun. Just once you get the shortcuts, you got to get past the initial part. Once you get past the initial part, the other part to me is fun. So I might need some more space. I'm going to try to work with this space first. Okay, let me try to work with this. So we have this f of x. Somebody else is left. If somebody asks them to let them back in, I'll open it up. Oh, what's the time? 30. That's fine. So we have this f of x, and we're asked to find the difference quotient. To me, the simplest way to see difference quotient is we break it out. Let me give myself some space, because I already know this can be a little bit like lengthy at times. So I'm gonna give myself some space. I can delete that. I want to crop this. Let's copy. I'm gonna add a page right here. You can drop it right. And then we're gonna do like this. We're ready to rock and roll. Let's go paper. Actually, let's go to view and paper. Okay. Can I move that out of the way? Oh, that works. Okay, anyway. Let's see. Okay, difference quotient. So to me, the simplest way to do difference quotient is to break it up into parts. What's somebody's favorite color? What color you feeling? Anybody got a favorite color? Oh, blue. Okay, I can get that one blue. So we'll do this first part. We'll do this part in blue, right? Okay. So if we focus on f of x plus h, let's do it this way. So if we focus on f of, again, x plus h, we're going to take f of x and replace all the x's with the blue part, right? So what's our f of x? We got 2. First thing I'm going to do is replace each x with a blank set of parentheses. So we're going to say 2 times x squared minus 3 times x plus 5. Okay. And then now, again, we insert the blue thing, which is this guy, x plus 8. X plus 8. We need to expand this all the way out. So the first part, okay, sorry. The first part, if we expand that binomial out, we'll get x squared plus 2xh plus h squared. We can distribute the 3. We're going to get a negative 3x minus 3h, and the plus 5 comes down. And then if we go one more step, we'll get 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 5. Okay, that's that one. So now we want to do the f of x plus h minus f of x. So we want to do f of x plus h minus f of x. And that's going to be, again, the whole thing that we just got, 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 5. Then we're going to subtract f of x. So we got to distribute the negative. Minus 2x squared plus 3x minus 5. Okay. If we combine like terms, let me see. This cancels this. 3x. The 3x cancels this one. The 5 cancels the 5. Okay. Let's write what we have as a result. So we have 4xh plus 2h squared minus 3h left over. Okay. Then we want to do the final part. We want to say basically this f of x plus h minus f of x. We want to divide it out to h, right? So that's going to be, now if I look at these terms, they all have h. I'm going to go ahead and factor out an h from all of those. We're going to be left with 4x plus 2h minus 3. Again, divided by h. This cancels this. And I think that's the desired result that we wanted. 4x plus 2h minus 3. Oh, that was an adventure. Let me see how many more. Okay, we're essentially done in time. We're doing pretty good on time, actually. So paper like this. Let's go view single page. Okay. Moving along. Keep going. And I think that's what we got. 4x minus 3 plus 2h. 4x minus 3 plus 2h. All right. Let me see. So we kind of need to sit tight for about 8 more minutes. I don't want to let you go before 3:20. We can use the rest of the class to just kind of like work homework sets. So like if you wanted to work on your homework or if people had questions, I'll go ahead and make it so that you can unmute yourself, and we can work homework sets or answer questions. We'll go to view, seamless. All right. Okay, so like if you have a question, feel free to unmute yourself. And otherwise, let's just kind of work on our homework for until about 3:20. I just don't think it's a good idea to stop before 3:20. But we can stop once we hit 3:20. Then we'll go ahead and call it a day. Okay. Otherwise, I'm just kind of here. Again, like this is just a good time to just kind of like really just kind of working on our work. Also, if you're working in Pearson, you can make use of the Ask My Instructor, and I can pull it up here, and we can talk about it. Okay, guys. I know I said 3:20, but if there aren't any questions, I'm actually gonna let everybody go. I think it'll be okay. All right, guys. If you don't have any questions, have a good weekend. So we finished 1-4 this week. Next week, just go ahead and do the best you can to kind of work your way through section 1.5. All right. Have a good weekend, and I'll see you all on Tuesday. Take care.
Hey, you too.
Yep.
Thank you.
My pleasure.
Thank you, Professor.
Thank you.
Yep.
Have a nice weekend.
You as well. Take care. Okay. Let's go like this.